Hi everyone. So I hope you had a good experience with the midterm and and sorry for being quite late to post the lectures. Um, lectures of this week. So, I'm going to say a lot of things about differential equation for the next couple of weeks, and then which is essentially going to be the chapter 7 of active calculus. And eventually I will start posting assignments also. Meaning, by the time these videos will be posted in Canvas, you can also will be able to see the assignments to be submitted next week. However, the assignment deadline will be around Friday. Friday of the next week, meaning it will be around 27th of February for assignment 4. And yeah, we will slowly bring our deadline back to Tuesdays. So don't worry. Let's focus on differential equation for now. So this video is about introduction to differential equation, chapter 7.1 of active calculus. And what we are going to talk about today is what differential equations are and what is it we do with them. So what are differential equations? Well, these are equations involving two functions and its derivatives. Meaning, for example, let's look at this differential equation. So what does this differential equation mean? So let's identify the elements. So first of all, y of x is a function of x. So this y is same as this y over here. So, so when I give you this differential equation and ask you to solve it, what I mean? What I mean is as follows. So find a function y in variable x such that the derivative of the function is x squared. Okay, so you have to find function y for which the derivative is x squared. And you can see there are a lot of functions, right? You can take y equals to 1 over 3 x cubed, right? Just check. Then d dx of y is d dx of 1/3 x cubed, which is 1/3 3x squared, which is x squared, right? Meaning, so all this calculation imply that d dx of y is indeed x squared. Notice that we are omitting, we are not writing yx every time, right? So I should write yx here, right? So if I choose my function y to be 1 over 3x cubed, we can see that its derivative is indeed x squared, right? And not just x cubed, I can choose a different y, right? I can choose it to be 1 over 3x cubed plus 2, right? Even then, you can see that d dx of y is still x squared, right? So notice that any y that looks like 1 over 3x cubed plus some real number where, okay, I should notice that for any real number, C, the function defined as 1 over 3x cubed plus C is indeed satisfies the equation. Okay. By the way, I should I should be more careful. Um, so any such function that satisfies this equation will be called a solution naturally, right? For example, this guy is a solution. This guy is also a solution. Any function of this form is indeed a solution. So if y is a function satisfying the equation, I mean, by the equation, I mean this equation. The equation one will be called a solution. So any function, so for any real number c, yx is a solution for equation 1, right? So given any differential equation, a function that satisfies the equation will be called a solution. And you can see that yx equals to 1 over 3x cubed or 1 over 3x cubed plus 2 or 1 over 3x cubed plus any real number will satisfy this equation, meaning all of these functions is indeed a solution. So question, how many solutions does this differential equation have? Infinite, right? Because for any real number, 1 over 3, any real number c, you get a solution, right? 1 over 3x cubed plus c. So there are infinitely many real numbers, so there are infinitely many solutions, right? So this is the first part. So I hope now you understand what differential equation means. By the way, not all differential equation will look like this. For example, this This is also a differential equation. Okay. Then it can have a lot of solution. For example, this differential equation has infinitely many solutions. Okay. So this is the first step. Also, I should mention what's initial value problem. So for example, look at this equation. Solve. So what does this mean? So exactly what we just saw last time. So find a function. So again, find a function y such that dy dx is x squared, and additionally y must satisfy that y0 is 1. So yes, you have to find functions y such that its derivative is x squared, but at the same time, it should also give you 1 when you plug in 0. For example, we saw that y equals to 1 over 3 x cube is a solution. So call this solution to equation 1, right? But what is y0? y0 is 1 over 3, 0 cube, which is 0. So call this equation 2, okay? So y0 is 0, not 1, right? Hence, y equals to the function 1 over 3x cube is not a solution to equation 2. Okay. So this kind of equations are called initial value problem, where you have a differential equation, fine. But additionally, you also specify a particular value of the function y, which we call the initial value of y. Okay, this might not be 0, this can be 2, this can be anything. This 0 can be any real number and this 1 can be any real number. So you are specifying one particular value of the function that you are looking for, and these are called initial value problems. So what is the solution? Well, see that yx equals to 1 over 3x cube plus c are always a solution for any c, any real number c, right? So what is y0 then? If you plug 0 in this equation, you get 1 over 3, 0 cube plus c. So which is c. And you want this, you want a y such that y0 is 1, right? So if you compare these two, what does it tell you? So if you choose c equals to 1, that is yx is 1 over 3 x cubed plus 1, you can see that the function y satisfy equation 2, right? So meaning 1 over 3 x cubed plus 1 is a solution to the initial value problem. Initial value problem. So IVP reads for initial value problem. Okay. So this is what differential equation and these are what initial value problems are. Also, now given a DE, a differential equation, okay, there are two problems or two types of problem regarding differential equation. Number one, which is forming a differential equation. So differential equations are typically motivated by problems of the physical world. And it is sometimes very challenging, to be honest, always very challenging, to actually describe a differential equation to actually form a differential equation that describes the natural phenomena. For example, maybe a car is moving in a certain road with a certain speed, and you want to find out the velocity of the car or how much distance it has traversed, and you want to form a differential equation regarding it. So this is okay, this is a classical problem in physics, but I mean, that is my point. Like I'm trying to like motivate why forming a differential equation is important. So you declare variables that describe velocity, that describe distance, that describes time, and then write down a bunch of equation using them that would ultimately like give you a description of the velocity of the object or how much distance it has gone or how much time it will take to go to a certain place and things like that. You will see a very concrete example very soon, but my question is forming a differential equation is indeed a very challenging stuff. Now, the second type is about solving a differential equation. Solving a differential equation. And we are going to spend most of our time on this type too. We won't must spend much time on forming differential equation. So given a differential equation, there are many ways to solve it. Sometimes a differential equation is not going to be solved. It's not solvable, but definitely we are not going to talk about those in the course. We're going to talk about those differential equations that can be solved, but there's a way of solving them. So for the next couple of weeks, this is going to be our task. Either find out mostly what methods are available to solve a differential equation. Also, there is one more thing I should specifically mention, which is order of differential equation. So it is, I mean, it is like what order of differentiation you are doing in your equation. For example, this is order 1. Since as only as the highest derivative, highest order of derivative of y in the equation is 1. Okay, if I look at this equation, d2y dx squared dy dx equal to sine x. This is order 2. Y two, because you are taking the second derivative of y. So if there is like third derivative, maybe something like d cube dx cube y, or sometimes we write it as, y cube plus y squared equals to x. So this means we are talking about the second derivative of y. This thing, we are talking about the third derivative of y. Then this is the order 3 differential equation because you're taking the third derivative, right? So that's it. Okay, now let's try to solve some problem. So let's talk a little bit about forming differential equation. So describe the following event using a differential equation. Number 1, your money will grow at 3% interest. How would you describe this event using a differential equation? So first step is declare your variable. So I'm solving the problem. So let T denote the time and a of t, a function in the variable t, is the function that represents the amount of money in your account after t years. So the unit of time here is in years because it's annual growth, right? So this is annual. Okay. So what should the differential equation then? So for example, So what is this quantity? So d dt of A, rate of change of your money, which is the function A of t, right? So it is like in 1 year, how much money has been like deposited in your account through the interest rate. So that's it, right? So maybe your money after 2 years is A of 2, your money after 1 year is A of 1. So A2 minus A1, this difference, how much money has changed or how much money has been deposited through the interest rate is represented by the function dA dt. Okay. So this is the rate of change. And what is that? As you know that thanks to the interest rate, this is 3 over 100 times A. Because what is dA dt? The amount of money that has been deposited in your account in a year through your interest. And your interest rate is 3%. So it is like 300th part of your money, A, is being deposited in the account. Right? So this is a differential equation. The rate of change is equal to how much money is being transferred or deposited and things like that. Okay. Okay. So maybe we try to do activity 7.1.2e. So a can of cold soda is sitting in a 70-degree room. The temperature of the soda warms continuously at the rate of 10% of the difference between soda's temperature and room temperature every minute, right? So what is the differential equation describing the event? So first again declare variable. Let let the function A of t denote the temperature of the soda bottle after t minutes. So let's take minute to be the unit of time here. Okay. Then again, what is rate of change of the soda's temperature? dA dt, right? This is the rate of change of soda's temperature is dA dt, right? And what is that? What is the rate of change of soda's temperature? You can see the soda warms continuously at the rate of 10% of the difference between the soda and the room temperature's difference, right? So the rate of change of soda's temperature is 10%, meaning 10% mean 10 over 100, which is 1 over 10, times the difference between the soda's temperature and the room temperature, which is 70, right? So that's the amount of change the temperature has gone in a minute of times interval. So DADT means in 1 minute how much temperature has changed, and it is told to you, right? Like if at t minute the difference between the temperature of soda and the room is say something, then its 1/10 would be the rate of change of Thor's temperature. So this is the equation describing it. Makes sense? Okay. So now I have spoken a little bit about this forming differential equation. Now let's try to solve it. So part 2, solving differential equation. And how do you do it? Well, in future you will be seeing a lot of examples. But for this lecture, I mean for this video, we're going to do the most, the naivest method is, as you know, perhaps guesswork. Okay. For example, ds dt, and as you know, this is so naive it doesn't work. So so and then verification, of course, guesswork plus verification. So we will mostly focus on verification for this lecture. Okay. Guess. What is the guess? Guess is maybe, 2t square plus t. Now verify that st equals to 2t square plus t is actually the solution. So how do you verify it? Well, so verify that st equals to 2t squared plus t is indeed a solution. How do you do it? Very easy. Find out ds dt, which is d dt of 2t squared plus t, which is 40 plus 1, which is RHS. And this is LHS. Right? So LH is equal to RHS. So S is indeed RHS. So 2t squared plus t is a solution. So for this chapter, most of the assignments will be about verifying a particular solution. Okay, that's it for this lecture. And in the next lecture, I'll talk about more concrete way of like solving differential equations.